No. But quite often you'll get given a diagram on the paper and it will say find the angle, for instance, if you're doing trigonometry, or find the length of from here to here. And if you can't visualize that as a three-dimensional object, it just looks like a flat bunch of lines to you, then you'll struggle to understand what it means. So a good way to do it is to practice drawing certain shapes and doing them in different orientations and things. And that will just help you to visualize it. So what I'm going to do, because this is what happens in exams, I'm going to label my points, my vertices. Okay. So every corner of my cuboid has got a label. So then we can talk about sides and lengths and faces. Right? Because that's what will happen. They'll say, what is the angle that this line makes with that face or with that edge or that kind of. Are you all okay? Because I'm assuming you understand from year 7 edges, faces, vertex, corners, things like that, yeah? Say that again? So a point where things meet. Yeah? What's a vertex in a quadratic parabola? So it's the lowest point, and it's also called a turning point. Alright? When we do gradient and things like that. So we could maybe think of it like that. If we were going along the edge of a shape, we turn at a vertex. So it's a corner. Alright, so for instance, we've just got to identify some right angle triangles. So a common problem that's given to you is, let's say this was a box on the back of your scooter when you've got them. Alright? What's the longest stick I can fit in the box? C to D.
No, actually C to F.
Oh.
C to F.
I meant C to D, but then I changed it to C to F.
No, it's D to F. C to E or D to F.
Or C to H or A to G.
It has to be like
Okay, so it's diagonally across. So for instance, do you mind, just because it's easier, I'm just used to drawing it, I'm going to go, right, I'm going to get rid of the dots. If I go from B to H.
Oh, I see.
So that's lying, one corner is in the bottom corner of my the box, and the other one's in the top corner, diagonally. So I've kind of got a double diagonal, haven't I? Alright? So, my question then is, let's say I know the dimensions of the box, how could I work out the length of that line? So,
how tall is it?
so let's make up some numbers, and let's say that it's, what do we do, 30 centimetres wide by 10 centimetres by,
Because it's a cube.
well, let's do it 8.
I thought it was a cube.
But a cuboid is not a cube.
I thought I had to have
A cuboid is just a three-dimensional box shape. Okay, now it doesn't quite fit because of the length I've got. Oh no, that's right, actually it is 10, 8. The height is slightly less than the width. Okay, so let's say I know those 3 dimensions. How could I find out the length of that line? What do I do?
You can use the 30 centimeters and the 10 centimeters to find like hypotenuse across, like flat, and
Okay,
then use that.
so what we're doing first, we've got to identify the, what are you doing? You said hypotenuse, which means you've identified the triangle.
triangle.
So what I would say is, this is one of those multi-part questions. So you can't immediately work out that length until you know it. And there's a couple of ways to do it. Alright, so what we could do, I think what you're saying is, we know that length, we know that length, so what we could do is work out that length across the top of the box. Okay, so that line there, B to G, is on the top face of the box. Alright? Now, why would I want to work that out? Because that, if I say that's X, Hayley?
It's the bottom face.
Okay, so that line then is part of a triangle which is perpendicular. So actually, if I work out X, that then becomes one of the sides of the triangle that is vertical through the box. Now, normally I would have done it on the bottom of the box, but you did it on the top.
Yeah, I just saw the labels.
Yeah, that's fine. But does that make sense? So if you think about a box, it's quite nice. If you struggle to visualise, it's quite nice to actually make them. So basically, if this is a box, this is the cuboid. What we have to do is work out the distance which is from this corner down to that corner. Alright? So what we've done is worked out the triangle that's on the top of the box. So I know that diagonal across the top face. Alright? Now I might actually, if I draw it, maybe if you're struggling at all to visualise, if I say, right, so this triangle is kind of in that direction on the top face, and then this one is actually going down. I mean, it's difficult because if you can't visualise it, you struggle to visualise it, whatever I do, but we'd actually have to build it. Is there anyone that is struggling to visualise? Or are you all okay with it? Okay? Alright. So let's solve the problem then. So we want to know X, so that will then enable me to work out Y. So I know, for instance, that Y squared equals 8 squared plus X squared, yeah? But I've got to work out X first. So X squared equals 10 squared plus 30 squared, yeah? Now you'll notice that I don't even need to square root because I've got X squared and X squared. So actually what I could do is to say that Y squared is 8 squared plus 10 squared plus 30 squared. Which is quite nice because then actually we start spotting a shortcut. I'm not going to say it because I want you to spot it for yourself if you want to use it. So X squared, okay, so all of that goes instead of that.
Can I say the shortcut?
No, keep it to yourself because I don't want people to jump to it and think, yeah, that's what I need to remember. That's not. If you've got it for yourself, great. If you've spotted it, great. If you haven't, carry on thinking, you know, what do we actually have to do? All right. So then we know that Y squared is 64 plus 100 plus 900. So Y is the square root of 1064. So for instance, a question like this, I might say to you, give your answer to 2 decimal places or 3 significant figures or something like that. But if I rounded X halfway through, I'd get a slightly different answer, wouldn't I? And there's no need to round X. So really, we've kind of got to think, that's just one problem. Are there any other triangles that I could find in the cuboid?
That are different.
Yeah, what other questions could they ask you to find?
One with the middle side of the box.
Yeah, we could utilise the end. We could put. There are lots of right-angled triangles in it, aren't there? Yeah. A lot of them are very similar, just the box turned around, same sort of idea. But that's a normal one, which is how long is the longest rod, you know, that can fit in this box. That kind of. Yes.
Could you still find y if you use diagonal from
If you use the diagonal from F to A, well, F to H. Well, I tell you what, let's have a look. So let's see whether we could approach this question differently.
To draw different.
Well, I tell you what,
Oh no, never mind.
you don't do it at the moment. Let's just draw this. We're going to do some different shapes in a second. So let's. So what I want to do. I mean, there's various ways to do it. So if I want to find this length again, right? We did it on the top. We could do the same thing underneath. Is there any other way that we could do it? I guess. What about this? Is that triangle right angled?
No, yes.
Yes.
It's right there.
Yes.
At the top.
Is it?
No. Yes.
No,
no,
it's
because
left.
it is.
It's left.
Yeah, it is.
No, because it would be across to the bottom corner, so it would.
It is.
It would just be like lifting the line
It is.
down.
Why does it have to be right angled?
Because it's along that thing.
Because these faces here are at right angles, yeah?
That's so weird.
It's difficult to visualize, isn't it? But logically, it's like, it has to be.
Wait, I'm gonna.
Because this line is on one face here, this line is on the other face, and those two are at right angles. Therefore, this has to be a right angle, eh? It's just slanted down. So it'd be like, take this bit of paper, here's the box, lie it like that, and then just sort of, the paper's a bit too big, right? You happy that that's all right angles? It's the right angles on top. If I just lie it down like that across,
Because it's along the thing.
it's still a right angle up there, yeah? Which is that's the one you're looking at, isn't it? That's the one. So if I made it a triangle, which is what I've done, that is still a right angle. It's still up there. It doesn't change it. But it does look a bit dodgy, doesn't it?
You have to like calculate more stuff.
So, what do we actually? So what are we trying to find? So I know that that's 10. I know that that's...
Other way.
Sorry, that was 30, that was 10, that's 8. If I want to know this line, I know that one, I've still got to work that one out.
That one's a corner to corner.
So that was a corner to corner. So actually, I still only need to work out
Oh, one thing.
one other
That's-
triangle.
8 is A, 10 is B.
Couldn't
and
you just find the
7
area?
Is it still not 30 squared plus the result of 10 squared plus 8 squared?
Yeah.
So will I not actually just get exactly the same thing, just in a different order?
Couldn't you technically just work that side out like a
Yeah.
square? Like
Like it's X.
like an area, because it's 10 plus a 10 times 8, so 80, and then divided into half because it's a triangle, 40.
So it's the area, but I don't want area, I want the length of the line.
Oh, okay, yeah, that's probably.
Yeah. But different way of approaching it, but we actually end up with the same numbers. Yeah?
But you don't have to use the 30 to find the green triangle.
No, I'm not using the 30 to find the green, I'm using the 30 to find the pink.
Oh. Yeah,
But to
because
find
the
this
green
side
is
of the
allowed.
pink, I need to use the green.
Yeah.
But how do you get the same numbers for y?
Okay, because this is y still,
Yeah.
This is x. X is in a different place. Y squared is still 30 squared plus x squared. And x squared is 8 squared plus 10 squared. So I still end up with the same thing, right? Even though I'm using different triangles, supposedly. Alright? Different way of doing it, same thing. Alright? Okay, so we've got our right angle triangles. They're easy enough to spot. What about, now maybe you need to go on to the other side. Right? Pyramids.
Oh.
I know how to do it.
It's the bottom. Wait.
So let me give you a tip.
Wait, there's 2 different types out there.
Well, there's lots. So we're going to do a pyramid. And this is the way we're going to do it. You ready? You're going to do this? Alright, before you start drawing, it's what we do to make sure we get a nice looking pyramid. What I want you to do is, with a faint line, pick a point that's going to be in the middle of the base of the pyramid. So I'm going to pick it here, and I'm going to draw my line straight up.
Oh, I see it.
And then what I'm going to do, from this point, I'm going to go either side the same distances and make a cross. What I'm then going to do is, to draw my pyramid, I'm going to join
That's really good.
Oh, wait. Lines on there.
Well done.
That's one way to do it.
I don't like it.
That's a pyramid? Oh, I see.
There is, obviously we can do it other ways. So again, if I make my line like that, I can actually use this as a central point and go around it in a different way. So I'm going to go my base now.
Okay, it's only this. It looks like it's a circus tent, and that's basically a pyramid.
So if I draw that around it
Pretty much the same need.
and then do this. The trouble with that way is I hide the sides. Alright?
Yeah, now it feels like it looks like pyramids to me. Like I look down
Yeah.
and it's like, what?
Now the reason why I kind of, although this one looks dodgy, it's because of perspective, right?
It's all about perspective.
Because I've not drawn it with perspective, so actually you're looking at it thinking at the back it should be coming in. So actually the back face is wider, isn't it? However,
It's not real life.
no.
It looks like they
This one's real life.
But what it's useful for is identifying the triangles. Okay?
Should I have made all of it a square? Because I did not.
The line in the middle, does it make you mad? Take that out.
No. The reason is because where are my triangles? So I have a right angle triangle from a corner to the top and using one of the edges. So I have a triangle.
Does it matter that my thing is a lot wider than it is?
Doesn't matter as long as you understand about finding right angle triangles in pyramids. It doesn't need to look amazingly brilliant. So there's one triangle. Do you understand where that is? Can you visualize it?
Yeah.
Okay? So I've got those going from the centre either way. Okay? What would it be if I drew the triangle the whole way through? What kind of triangle would it be?
Equilateral.
No.
Isosceles?
It would be an isosceles. It
Oh, yeah.
could be equilateral, but it's not necessary.
Wait, hold up. I have to try to color on it. That's hard.
There is another couple of triangles. Anyone know where?
Yes,
Down
it's
at the
mine.
bottom. Like
What do you mean at the bottom?
on the
square. Like if
I know it's
there.
So if I were to actually go from the middle on the face, so I'm actually on the slanted face of the pyramid.
Oh.
Bless you. I also have what?
Oh, I was thinking.
Okay, yeah, I think I know what you were thinking.
Yeah.
Now
Triangle, triangle.
that one, I tell you what, before you do this one, I'm gonna actually show this one on that diagram because it makes more sense. So let me delete that. What she's shown is the one that looks like this. So if I'm on one of the slanted faces, I actually go on the face of the pyramid rather than using the base of the pyramid. Okay. So I tell you what, stop drawing at the moment, and I'm going to give you a few minutes afterwards to finish these off. So just watch with me what we're doing. I want you to actually look at when I'm constructing them so you know where they are. You can go back and draw them afterwards. So do you understand the difference of the one that's using the base and the one that's using the face? Okay? There are others. I think the one Sophia was now, I presume, is it a right angled triangle that uses the base itself? Is that what you were thinking of?
Half of it.
And
Yeah.
half of it. Both of those would be right angled triangles, wouldn't they? A big one and a smaller one. So that's flat on the base. So over here, that one would look like this, wouldn't it? It'd be on the base of it. Alright, or half of it. There is another one, Leila?
If you go from the top left point to the bottom right point.
So
like
from
no,
here,
not from that top, like the side, top side. Yeah, and then you go across and then up.
so that's another, across and then up.
And then you make a big full triangle.
Ah, but that's not a right angle, is it? That's the same as doing this one, but going all the way across. Yeah, and that's what we said was the isosceles. So we've got lots of the same. We could take this one on the base and put it anywhere on the base. It's still a right angle. Like this purple one could be to any corner. That's still a right angle. There is a different one using different dimensions, which is going from the top down to the middle again,
And then to the corner.
not to the corner.
To the side.
To the side. If I went across to the middle, and then I go like that. And now what that would look like on this triangle would be like this. So I go to the middle and go up.
Isn't
That
the
triangle is
same
really
as
confusing.
Okay?
Oh, I see.
I'm looking at all of them,
It looks
but
like
that
a
one.
why not get that one? It's going in the middle of the
I get it, but like I don't like it. That's all.
Yes, Len.
Could you do a slanted triangle like the cuboid in the
Um,
Is there a possible way?
well, the trouble is, isn't there, we're lacking the points. In a cuboid, we've got more vertexes to use, haven't we?
Maybe I'm just getting confused.
In this one, we've only got this top to use.
Then no.
Right, so a couple of things we need to understand. Just labelling, which is, okay, this here, so you've got to label on yours, this length, alright, okay, so if I go from M to P, MP is called the height of the pyramid, okay? Right. If I say this point here, x up to p, x to p is called the, it's actually called the slant height. So that's where some people can get it wrong. If I say to you, what's the height of the pyramid, I want to know from the centre of the base up. If I want to know the slant height of the pyramid, I want to know the height from the bottom along one of the faces. So that would be this line here, which again I can do using that right angle triangle. Yes?
Where is it on the
What's what one?
XP, but on
Oh, that's on this face. So if I were to draw that,
Like the middle from. Middle
yeah,
from
so it'd be
there.
like here, be on this, be there, wouldn't it? It's difficult to see.
Could it be like under the bench?
Can you color it? You could do it next to the purple and show that face on.
Yeah, I could do it from, let's say, from here up to there. and
Whoa,
along.
that was so confusing.
Or you could do it on the other side so it's not so close to the purple.
Yeah, I could do. You could do it any way you like.
I don't know what that
It
is.
has to be from the middle.
Yes. So this blue one is on the face from the middle. Because remember, if we come from the top to the middle and then along the base, that's where the right angle. So remember, what we're looking for are the right angles. So that's a right angle. That's a right angle. Where is it? This is a right angle. These little ones are right angles. That's a right angle. You know, that's a right angle, and so on. Yeah. This is a right. So we're looking for right angled triangles only.
Are you looking at this one, the left one? Like the point is away from you, or the point towards you?
Which point are you talking about?
The pyramid on the left.
Yeah.
Is it the point away from you? Or the
Which point are you talking about?
P.
Point P's going up, straight up.
But it can go away, right? Too.
No,
No, then it's
Yeah,
it's a
'cause then
pyramid. I want the P to be directly above the middle of the base.
You could look
Otherwise, it's a different shape, and I've got different triangles. So, for instance, maybe what you're thinking about is a shape. If I were to draw, and you can do a bit of exploring of this yourself with the drawing. What if I were to draw like the base of a pyramid, but it's rectangular? But what if I didn't put P directly above the base? What if I put P directly above the center of one of the sides? So if I were to now draw that, I am now basically making an L shape, like a shelf. Do you get that? So it's like my laptop shape.
Oh yeah.
Yeah? It's my laptop. So that's my screen, that's my keyboard. So if P was actually on the face there, all right, so not a pyramid, I think this is what you're saying, P would be to one side, that would change a lot of things, wouldn't it? So that would then, I would then still have triangles. So I would then be like, well, here's one triangle using P, and it would be a triangle like that. Okay. I could have other triangles along the back face as well. Alright?
I was just like, you can look at like, say like you have like a physical pyramid like in front of you. Like the diagram, like it could look like through the bottom, like.
Right, I get what you mean now. It's not away from you. It's,
Yeah.
yes, I see what you mean.
Could if you did, right?
Yeah, I could think of that as the top or the bottom, is what you're saying, yeah?
Yeah.
Yeah.
Right?
I get you now, yeah.
So that, not the top point, but the back, is that the back point or like?
See, me, I'm visualizing in my head that X is coming towards me, but to the right hand side. So for me, this is the back of the pyramid, and this is the front of the pyramid. So if I look at like, this is a pyramid, that's what I'm looking at, like that, and that point there is, well, that would be X, for instance. The orange triangle would be the one, the front side of it. But that doesn't mean that's how you have to visualize it. Actually, only matters where the triangles are. Right, just going back to this one, this is actually quite useful because it's like a laptop shape and I've got triangles, but what shape could I turn this into? Could be a cuboid, but then I'm going back to it. But I'm thinking of,
Oh, a triangular top prism.
okay, so a triangular prism. Okay? You might call it a wedge or a doorstep or, but it's a triangular prism. Alright? Got that? Right, one that we really struggled to draw using isometric paper.
Oh no.
It's cylinder. A cone.
Okay, so you might just have to...
Oh yeah.
Don't we get the formulas for that though?
Well, it's not about formulas, because you've got formulas for areas and things like that. But can you visualise that as a
Yeah. Actually, yeah.
cone?
How did
Yeah?
you do that?
A circular-based pyramid.
There's no like
points,
No, so I've just kind of done a circle, and what you might need to do is try and draw an oval with one of the dots as the middle of your oval, and then just draw straight up. Now, here's the question: how many triangles?
2, 4.
Infinite.
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 Because the triangles do from the centre out and then up, and again it's the slant height of the cone. And how many of them make up a cone? An infinite number. Yeah. What is the length of, or that side of the right angled triangle also? It is the radius. It's the radius of the circle of the cone. So I could ask you for triangles in that sort of shape as well.
But you would have to give us like.
So normally, for instance, this length here would be L, which would be the slant height, again, like in the other one. This one would be the height, and there is a formula for the surface, the curved surface area of a cone, and it includes L and H and things, so you need to know the difference between L and H. But what we're really looking for at the moment is where are the triangles, where are the right angled triangles to then do Pythagoras' theorem. Alright? So although we've only done that very first question on Pythagoras' theorem, you can see where it's all coming from, yeah? Alright? So I could work out how long it is along that face. Of course, with a wedge, you also spot there is right angled triangles that are on the faces as well, yeah? Slanted ones, yeah? The ones that are not upright. And it is all about visualization. Okay? So, well, what I really want you to do now, because you've only got 5 minutes left, is just get your diagram sorted so you know where all these triangles are.